The sun is finally catching up, but I'm still winning because I'm up. And so when it comes to this particular video, I already did the summarization. That's great. But this video, it needs to be a little bit longer. I'm going to do my best to explain as much as possible. And I can't say stop me, but you can pause and just make sure it makes sense as you go along. Again, this is video 3. This is the analysis of the data. And again, let's imagine, and how I approach this is imagine we have some statistical questions, okay? And so do I have this in the notes? Maybe I don't. I'm gonna put this in the notes, the actual questions. All right, so here we have one categorical variable, and it really I need to change this. I didn't do this before, but this needs to be binary, okay? Because we're gonna consider a binary situation, and the analysis for the binary situation is going to be only works currently for categorical binary variable. And again, we're going to look at whether they collected a sticker or not. Collect stickers. Okay, so collect stickers. Okay, collect stickers. Maybe the question is there. Yeah, it is there. Good. So can we statistically confirm that the population proportion? Here's keywords: population, the proportion of Cal Poly of. That's interesting sentence. That's not what it's supposed to say. Sorry about that. So can we statistically confirm that the population proportion of sticker collecting students at it's supposed to say Cal Poly is equal to some value 0.5. I don't know why it took that way the question 0.5. All right. And so what I'm going to do there is doing it by hand. So doing this by hand, hypothesis test, I'm actually going to calculate the p-hat. The code looks funky. I'm sorry. But I actually kind of wanted you to see what it looks like. And so to do this, what we're going to do is first find p-hat, and that's this code here. And so what I'm going to do is I'm going to change the variable name to collect stickers. And then what do you think it should be? If I'm interested in those that actually collect stickers, what do you think I should label this as? Hopefully you said yes. It should be yes, because I want to know if they collect stickers or not. So this code right here, what this is doing is finding the frequency of those that actually collect stickers from the actual data set. And then this is dividing it. This is n row, the number of rows within the data frame. This is telling me the sample size. So when I run this, I'm just going to highlight. You have to just highlight this, because if you don't highlight this and just press the play button like I was doing it and haven't said that I was doing it, if you just run that, whole code is not going to work. You're going to error. You got to do one line at a time. If I run this, just do this. Come on, don't embarrass me. I get p-hat to get a 0.226, which is just 17 divided by 75. Here where it says proportion, I'm testing if it's equal to 0.5. So I'm just going to put 0.5 here, 0.5 here. If I want to test it for another value, let's say 0.75, I can also put 0.75. Standard error is p times 1 minus p over the sample size, square root of that entire thing. That's that. And then finally, this is the test statistic, the difference between p-hat and p over standard error. When you do this if you run all these now, if you actually run a chunk, it should all work now. So this is going to be my test statistic, the calculation for my test statistic. Okay, so now we have our test statistic. If you look here, it's negative 4.73. Our p-value is going to be very, very close to 0. In the video that I produced last week, or during the first week, I mentioned why we multiply by 2. It's because we're assuming this is a two-tailed test. It's legitimately taking our p-value, we have to multiply by 2. That's why this is happening. So when I run the entire chunk, I want to actually run it so I get the p-value. It's going to tell me my test statistic again is negative 4.734, and then I'm going to have a p-value of 0, meaning that we should reject our null hypothesis. I should have, if I had more time, I would have written out the null and alternative hypotheses, but then this is just the computer doing the math for us. Okay, and I even say that this is doing it by hand. There are functions within R that actually do it by hand, by calculation, and you're going to see this in a little bit in the video. But I want you all to at least see the process. This is important. It's for you to see the process. Okay. Now, in terms of confidence intervals, again, the categorical name is sticker collecting. Let's just copy and paste. Sticker. Oh, I guess we're not going to sticker collecting students at Cal Poly. What is? So when it says what is, we're going to find a confidence interval at Cal Poly. All right. So with that being said, change the variables names a little bit. So we know it's going to be collectors, collect stickers, right? It's going to be the variable name. And again, we're after when it's equal to yes, when it's actually equal to yes. And we already did a standard error from before. We're still going to calculate it again. And this little thing is different. This is where I get my critical value. This is the number of standard errors away from the actual point estimate, which is p hat. Okay? And so if I were to run this now, it would work. This is coming from the normal distribution. I didn't check. This is me not telling you to check your assumptions. We didn't check your assumptions here, but this would have been n times p is greater than 10, greater than or equal to 10, and n times q greater than or equal to 10. Our sample size is 75 times 0.5 for the hypothesis testing, and that's 37.5, so that's greater than 10. So therefore, we know that n times q, which is 0.5, is greater than 10 as well. But if we were to do this for p hat, that's going to be 17 and 58. So both of them are greater than 10. So us using a normal distribution makes sense. So this is okay. So this is again the function for me to find the critical value. If I'm talking too fast, you can slow it down. But this is the process for us to actually find the lower bound and upper bound. When I run this, and mind you, the only thing I changed was collect stickers and yes, and everything else is there for me to run. When I run this, this is going to give me the lower bound and upper bound. So it's 0.132 and 0.321. Notice, notice 0. I had to do that. 0.5 is now within the lower bound, upper bound, right? That makes sense. It's not plausible based on the data. It's not plausible based on the data. One thing that I didn't get to mention, what type of confidence interval this is. This is a 95% confidence interval, okay? Because we're taking 1 minus 95, that's alpha. We're taking it and then we're dividing it by 2, okay? So that's 95, you get 0.05, divided by 2, you get 0.025, and then we do 1 minus that to just include that interval of plausible values. And then here we go. This is our actual confidence interval. Okay, 8 minutes. Let's go. Thank you for watching. Let's continue. So imagine we're looking at one quantitative variable. Same thing here. We want to analyze just the sticker spending limit. I'm going to copy paste it here in terms of the visualization. Okay, and we saw that the actual mean is 1.26. Let's test if that actual value, okay, sticker spending limit, sticker spending limit. Okay. And we want to see, let's say that in my question, I already have it written down. I want to see that if it's equal to $2 on average. Let's see if the population mean is equal to $2. Actually, if you look at this question is not correctly stated because it should say is the population mean. Is the population mean that students at Cal Poly are willing to spend on stickers equal to 2. Okay, is the population mean amount that students are at Cal Poly are willing to spend on stickers equal to 2? Again, I'm going to extract the variable here. The amount I'm testing for, mu, is equal to 2, and then that's the only thing I have to change. And then now when I run this, I had to do another test. So notice I didn't have to, legitimately specify the actual statistic. I didn't have to specify the the actual value that we're testing. I mean, technically I did, but I had to do it in this format. I just gave it to the actual R and this using t.test function, and look, it gives me the test statistic. This is the test statistic. It gives me extremely small p-value, therefore I would reject the null hypothesis. So it's not plausible. 2 is not plausible based on the data. Okay. And so that's why it's not equal to 2. Okay. And notice that in terms of a 95% confidence interval, 2 is not included. Okay. And then this reinstates the mean that was given to us. With that being said, I can change the level of confidence. I can say conf level is equal to 0.99. We can, I think that's how it works. We'll see how, okay. So now we have 1.36 versus, and to 1.49, whereas before it's 1.09 to 1.43. For those students that didn't believe me that the confidence interval gets wider, this is proof. All right, it's getting wider with more plausible values when you increase your level of confidence. Okay, last analysis. I don't even know what minute I'm in. I'm pretty sure I'm in minute 10, but it's okay. We got this. You've gotten so far. It's starting to get light. Sun's starting to come out. So what is the population mean? Okay, what is the population mean amount of students at Cal Poly? Oh, okay, so this is just a confidence interval. You know, it's just for confidence interval because of time. I did this by hand. It will be the same amount, but I'm not going to spend time on that right now. You can try that on your own. Just because of time, you can easily get it from here. Oh, well, this is going to be on the lab, so so I'll finish it. So then here's when you can watch more of me talking about it. Stickers, okay. So what does the population mean? Again, what does the population mean amount that students at Cal Poly are willing to spend on stickers? Sticker spending limit, just change what the variable is, and then that should work. And so here I'm finding the mean, here I'm finding standard error, here I'm finding the critical value. This QT is the function for me to find the actual critical value. This is the degrees of freedom. We're using the t-distribution. Technically, we shouldn't be using the t-distribution, but just for our numbers to match up with what R is providing, we're going to use the t-distribution. And then this is our output, 1.0921 and 1.43. So if you scroll up to back when I did it originally, these are the same exact numbers. Okay. Boom, boom. So with that being said, that's important. That's definitely important. Variable. So this is the last analysis. Yeah, you made it this far. You made it this far. Good job. Here we know that one of the variables is going to be, based on the questions, I'm looking at them already. One of the questions is going to be, at least one of the variables is going to be sticker collection. I'm pretty sure sticker collection. And then spending amount. Spending on stickers. Spending on stickers. Okay. So what I'm going to do is I'm going to play the game, copy and paste. And the thing is, both of these questions, I know I'm going to, change the letters in them. Both can be answered from the R output. So I'm just going to use the R function. I'm not going to do this by hand. And this is what it is. And as you collect stickers. Boom. Collect stickers. And the order matters. So sticker spending limit right here. Collect stickers is right there. And once I run this is going to give me my analysis. And so one way of looking at this in terms of hypothesis testing, is there a significant difference between the population mean amount that Cal Poly students are willing to spend on stickers, depending on whether they prefer stickers or not. If they prefer, or if they collect stickers, if they collect stickers are not. Okay. And so you see that I'm seeing I want to know, is there a difference? So I'm seeing if the means are the same. I want to know if the means are the same. And so here you can do the same thing with regards to confidence interval and say, what are the plausible values? Look at the difference in language. What are the plausible values? know that this is going to be Cal Poly students. Okay. Let's do that there. And then what we're going to do is say stickers. Spend on stickers. I wish that didn't happen. So then there, once I run it, all right. So this is the test statistic. This is degrees of freedom. This is the p-value, right? Notice that 0 is included within the lower bound, upper bound. Remember, we spoke about this in class, or we're going to speak about this in class. Since 0 is plausible, what we're going to do is field of rejected null hypothesis, indicating that it's plausible for there to be no difference between the two groups. Whereas in this particular situation, in terms of the p-value, if you were to look at this, you probably would say, okay, I have evidence to reject the null hypothesis, yes, but it's not a lot of evidence at all. Okay, and so notice that this is zeros in between. All right, so here are the means as well. Well, I got tired. Let me know if you have any questions on this. We'll go from here. And I think that in terms of analysis, you all experienced a lot. And again, pat on the back for completing it. If you have an error, if you're confused, come learning hours. I'll be more than willing to assist and make sure that we're all on the same page. Thank you and have a great day.